Hey guys, today we're going to start working on some radical equations and inequalities. Um, let's start with some radical equations. So, to solve equations with radicals in them, you first have to isolate the radical. So this is number 1 on the sheet you'll see uploaded. Isolate the radical. So we want to make sure the radical is all by itself on one side of the equation. And in this case it is. So then we want to raise both sides to the reciprocal of the exponent. Now, for example, in this one, 2 minus 3x is really, if you think about it, 2 minus 3x to the 1/2. There's a 1 here and a 2 here. And when you change radicals to fractional exponents, you put this as the numerator and this is the denominator. So the reciprocal of 1/2 is 2, and 1/2 raised to the 2 would cancel. So in most radical equations, you're simply squaring both sides. But there are some questions you'll see today where you might have x to the 3/4 equals 8. You raise both sides to the reciprocal of 3/4, which is 4/3. And then on the right side, you would rewrite 4/3 as 8 to the 4, cube rooted. Do the cube root or square root, whatever this is first. Cube root of 8 is 2. 2 to the 4th is 16, for example. But if it's just a regular old radical, you could just square both sides. So that cancels. You're left with 2 minus 3x. 4i times 4i is 16i squared. I squared, we learned, is negative 1. So this is 16 times negative 1. And then you're home free. You have a simple algebra problem. 2 minus 3x equals negative 16. Subtract 2 from both sides. Negative 3x equals negative 18. Divide by negative 3. X is 18/3. Which is 6. 18 divided by 3 is 6. Now in all these questions you should really check your answers. If I take 6 and plug it back in, this says 3 times 6, which is 18. 2 minus 18 is negative 16. So is the square root of negative 16 equal to 4i? It is, because when you have a negative under the radical, you can move it out in front as a negative 1, which is an I. The square root of 16 is 4, so this is 4i, which is 4i. Let's try number 3. It's a little bit more challenging. By the way, the last step in our notes was solve. It's a little bit more challenging when you have more than one radical. So, you want to isolate each radical one at a time. Now, x minus 10, that radical is already isolated. And again, a regular old radical has an exponent of 1/2, so I'm going to raise both sides to the 2. Now make sure that you wrap the whole entire right side in parentheses and square it. Squaring and square rooting cancel. On this side, you do not square these individual pieces. It works out to be, unfortunately, radical 6 plus x minus 4 times radical 6 plus x minus 4. So we have to use the double distributive property on that. So radical 6 plus x times radical 6 plus x is 6 plus x. Radical 6 plus x times negative 4 is negative 4 radical 6 plus x. Same thing here in the middle. And then finally, negative 4 times negative 4 is 16. Now that we got rid of this first radical by squaring both sides, we could focus our energies on this radical, because you can combine these two radical 6 plus x's into negative 8 radical 6 plus x. 6 and 16 is 22. And we have an x. Next, let's keep going. Let's try to isolate this radical. Let's subtract 22 and x from both sides. Good news, that x cancels. You're left with negative 32. And negative 8 radical 6 plus x. Divide both sides by negative 8. We're left with 4 and radical 6 plus x. We can now that we have this radical isolated, we could square both sides. And then we could solve for x. X is 10. Let's check it out. If you plug 10 back into the original question, you get 10 minus 10 under a radical. That's 0. If you plug 10 into this side, you get 6 plus 10, which is 16. Radical 16 is 4. 4 minus 4 is also 0. So it checks. Alright, let's try a radical inequality. So these are on the next page. Let's try number 8. So there's 2 steps to solving a radical inequality. Step 1 is you want to set the radicands equal to 0. Well, I should back up a second. Anytime you have an inequality, you should build a number line. And on this number line, we're going to put what are called critical numbers. The first type of critical number is found by setting the radicands equal to 0. So radicand is a fancy word for the stuff under the radical. So 9 minus 2x. Actually, maybe I'll write it up here. 9 minus 2x, set that equal to 0. When you subtract 9 and divide by 2, we get negative 4.5. So that's a critical number. Next, we're going to change our problem to an equation and solve. So again, these 2 steps are to find the critical numbers that go on this number line. So we change this to an equal sign. We're going to solve, just like we did the last one. Let's square both sides, get rid of this radical. And again, when you square x minus 3, it's not x squared plus 9. We have to use the double distributive property. So we have x squared minus 6x plus 9. Let's move everything to the right side. And we get x squared minus 8x. Now we can factor this. Let's factor out a GCF and set each factor equal to 0. So again, these are 2 more critical numbers, 8 and 0. Now what we do with an inequality is we have a number line filled with critical numbers. We have 1, 2, 3, 4 sections of this. We want to test these sections. And probably the easiest way to do this is to, well, you should just take each of these sections, pick a number, and plug it in. Like negative 5. If I plug it in, what happens? 2 times negative 5 is negative 10. 9 plus negative 10. You can't have a negative under a radical, so this section is not going to work. Let's pick a number between negative 4 and a half and 0, like negative 1. 2 times negative 1 is negative 2. 9 plus negative 2 is 7. Square root of 7 on the left side. Negative 1 minus 3 is negative 4. Is the square root of 7 less than negative 4? No. What if we plug in negative 4 and a half? When we plug in negative 4 and a half, we get 0 on the left side and negative 7 and a half on the right. That doesn't work, so this is an open circle. What happens if we plug in 0? We get the square root of 9, which is 3 on the left side, is less than negative 3. No, so none of these numbers are working. What if we plug in a number between 0 and 8, like 1? 2 times 1 is 2, plus 9 is 11. Is the square root of 7 less than 1 minus 3? Again, no. What about 8? 2 times 8 is 16, plus 9 is 25. Is the square root of 25 less than 8 minus 3? 5. No, it's close. And finally, what if we plug in 9? 2 times 9 is 18, plus 9 is 27. Is the square root of 27 less than 6? Yes, finally. This section worked. So all the numbers bigger than 8 are solutions. So again, as a recap, set the radicands equal to 0. Put those numbers on your number line. Then change this to an equation and solve. Put those numbers on the number line. And then test those sections, including the actual critical numbers, in the original inequality to see if they work. So please attend the Google Meet and watch this video over again if you have questions, and have a good day.